Welcome to the next part of our workshop. In this video, we'll be planning a complete flow rack together using the pipe racking system. It's not just a matter of connecting pipes and joints. The much more important question is, how do we turn the requirements of a material flow into a functioning racking system? As an example, we'll be using a flow rack with roller tracks and several material levels. Before we begin, here's an important note. In this video, we'll be focusing on the fundamental considerations involved in planning a racking system. You can find detailed information on assembling pipe joints, drive-in sleeves, or diagonal bracing in the previous workshop video. 7 tips for assembly. You can also find all technical data, load ratings, and design guidelines at any time in the latest user manual. 1. Understanding the flow of goods. The starting point for any planning process is not the shelving, but the flow of goods. Which containers are to be stored? How many containers are required at any one time? From which side are they filled? And from which side are they retrieved? In our example, the containers are loaded at the rear and roll down a gentle slope automatically to the retrieval side. This creates what is known as the FIFO principle. First in, first out. The containers loaded first are also the first to be retrieved. Particularly in assembly and production, this principle ensures a clear and standardized material flow. 2. Selecting the right containers. Only once the containers have been finalized do we begin the actual construction. The dimensions of the containers will later determine the width of each conveyor track. They also determine the spacing between the side guides. In our example, several container tracks have been arranged side by side, so that different materials can be supplied simultaneously. Our tip: always plan using the actual container dimensions and allow for sufficient guide clearance to ensure the containers run smoothly whilst being guided securely. 3. Determining the number of levels. In the next step, we determine the number of storage levels. This depends on the required stock of materials and the available space. Our example features several levels arranged one above the other. The spacing has been chosen to ensure there is sufficient room for the containers and that they can be removed easily. At the same time, each level should remain ergonomically accessible. Not every additional level automatically increases efficiency. 4. Planning roller tracks and gradients. The roller tracks are at the heart of a flow rack. They enable materials to be transported by gravity alone. To ensure the containers run reliably, the shelves need a slight incline. In the example shown, all the roller tracks have been designed with the appropriate incline. The required angle of inclination depends, amongst other things, on the containers used, their weight, and the roller tracks employed. A good starting point is an incline of approximately 3 degrees. Our tip: where possible, test the running behavior using the actual containers that will be used later. You can find out which roller tracks are suitable for your application and what recommendations apply to different container sizes in the user manual. 5. Structural stability. As the height increases, so do the stability requirements. That is why our example features several diagonal braces. These ensure that the shelving unit remains resistant to torsion, even under load. Equally important is the even distribution of load across all levels. The permissible loads for the pipes, joints, and roller rails must be taken into account right from the planning stage. The relevant load values, holding forces, and guidance on the design of diagonal bracing can be found in the user manual. 6. Take maintenance and restocking into account. A good flow rack isn't just about how it operates. Restocking must also be straightforward. That's why there should be sufficient space at the rear for supplying materials. Equally important are easily accessible roller tracks and joints. This ensures that any subsequent maintenance work or adjustments can be carried out without any problems. 7. Think ahead to future expansions. Material flows are also subject to change. New containers may be added in the future, or material requirements may increase. Thanks to the modular design of the tubular shelving system, additional levels or further roller conveyors can often be added with minimal effort. Similarly, the height of existing levels can be adjusted, or container widths changed. It is precisely this flexibility that makes modular racking systems particularly cost-effective. Conclusion. Let's summarize the key points once again. A good flow rack starts with the flow of materials. Container size, roller tracks, shelf spacing, and ergonomics determine the final design. Only then are the pipes, joints, and bracing appropriately configured. Thanks to the modular design of the pipe racking system, the racking system can be expanded or adapted to new requirements at any time. This results in a durable solution for a safe, well-organized, and efficient flow of materials. This video explains the basic considerations for planning a flow rack using a practical example. For the technical design, we also recommend the user manual. There you will find, amongst other things, information on permissible loads, roller tracks, joints, and further design guidelines. If you need assistance with assembly, we also recommend our workshop video, 7 Tips for Assembly, in which we explain the most important assembly steps step by step. This ensures you have all the information you need to plan your structures safely, cost-effectively, and with a view to the future.